Welcome developers. This video I will show how to solve some more advanced SQL problems. So here I will show a couple problems I got from codewars, which I solved. The first solution to the first problem is pretty long, so there's a lot of stuff to walk through. It's certainly optically very long. There's a lot of lines of code. However, the general logic, the flow of what's going on is short mostly. It uses SQL union, CTE, group by, aggregate, aggregate functions. And so let's start off by looking at this first problem here. I'm not going to exactly read through all of this. I'm going to post a link to the question itself, but basically we have a table called users, and so we'll select start from that. So this is an interesting table because this has this is a table of JSON. So these are JSONs, these are objects. I'm gonna spell that out because some people might not be familiar with that. So in coding we have things called JSON. JSON stands for JavaScript object notation, right? And it's just a way of storing object notation, right? And it's a way of storing key value pairs. So key value pairs is another way of saying like looking up data. So this might be hard to see, but there's these are comma separated, right? So you got the key here, this colon and value, and then a comma. So this is a grouping here. This is another grouping here. So the key of age and the colon here, so key points to this value 19. So in JavaScript object notation you can point to like a key such as age, a key such as I got that wrong. You can point to a key such as age, a key such as name, a key such as pets. So you call that and it points to this value. And so in this JSON object, and this is hard to see, and that's my fault. Okay, so this pets points to an array. Here's an array of even more JSONs. It points to an array of JSON. You could call it like a nested JSON, right? And so this SQL query will require us to access the values in these JSONs, in these objects, which is a little tricky, and it takes some finagling to understand like how to make it work. So the table we expect to see will look like this. So there's like an age group of 18 to 30, and we're finding that these are the preferred pet types, right? So it says it counts the preferred pet types for each age group, right? And it takes the most frequent, right? So it says these pet types occur 2 times a piece, and that is the most frequent. And so when we look at this array of pets, we see the type here, dog. And what we're trying to find is the most frequent type of pet that we're finding among users grouped for each. I'm trying to scroll sideways here. Okay, grouped for each age group. So yeah, it's quite verbose, but what we can do is we can start by looking up things by age group. So I can do this just so we can select. I'm going to show you how to just simply access how we can look up a key in each column data, right? From users where, actually I'm just going to leave this blank for now, where age equals or let's say age between 18 and 30. This is how in SQL we can query values between a certain range, as we use between keyword. So we're going to select this column, info. We're going to select pets. We're going to select this array here, right? From users where age. So we're only going to select, we're only going to look up these arrays where the age is between 18 and 30. So let's just run this and see what happens. Yeah, it throws an error. Okay. Yeah, it's more correct. Okay. So this throws an error because age is nested in the object. So we have to point to the age key, just like we had done here, right? So what we have to do is, I don't know if we have to do this, but I'm going to use parentheses here, where info, point to that key, and we're going to cast it to int just to cover our bases here. And we can indent here, and we're going to run this again. Okay, so these are all arrays where the values come from, where the age is between 18 and 30. And the way I solved this was pull the JSON from this, pull out the array elements. So there's this built-in SQL function. From this query. I'm going to go ahead and alias this also. So let's queue this, let's see what happens. Okay, so now we've pulled out all the JSONs nested inside those arrays. And the next thing we want to do is we want to, right, because our expected thing is we want these, right? We want the type of pet, bird, dog, fish, reptile. So what we have to do is we have to now pull out the type in each of these. So what I did was I made another query here. Select R, so we're going to select this column, R, and we're going to point to the type key. Now this is a little critical. I'm going to show you this also. Text, cast it to text. I'm going to alias it, I'm just going to call this C from here. And I gave really lazy short variable names or column names because this query gets so long that I have no other way. I really have no other way to cut down the lines of code. Okay, let's run this. Cool. So now we've pulled out all the types of pets that we see for users where their age is between 18 and 30. And I'm gonna show you what happens when we just use a one pointer here. See, when you only use a one pointer, you're gonna get these extra quotation marks, and that's really annoying. It's going to make it difficult to pass the test because in order to pass the test, it has to look like this. You can't have those extra quotation marks. So you have to add this. It's somehow a more correct way to use the types here. And another interesting distinction is Okay, so if we look at results expected for this first age group, we're going to expect to see bird, dog, fish, and reptile. And you might have noticed a pattern here, right? We got bird, cat, dog, and fish. So these arrays, they're going to have to be alphabetical order. So what we can do is immediately from here, we can just alphabetize it and run that. Okay, so now we're in alphabetical order, and this is going to make it easier. So now we just have to group these and put them into an array. So what we have to do is we have to group these into an array. We want distinct values into an array, and then we want to get the count of the most frequent distinct items. So we're probably going to get, right, so you see bird, this occurs twice, dog occurs twice, fish occurs twice. Reptile and rodent, they look similar, but they're not. Reptile and rodent, these are so the most common occurrence is bird and fish and dog, and they occur twice each. And so what I can do now is, okay, I'm going to move on to the next. Yeah, I'm going to make this a common table expression. Okay. We're going to make this a common table expression. So now this query can be accessed like anywhere in a big giant query. Now let's try to select, and we want to let it be known that this is a 18 through 30 bracket, right? Select 18 through 30 as group name. And this is the way I did it. I gave this an ID. I gave this an ID, and you'll see why. And let's do an array aggregation. This is an SQL function. C. We're array aggregating C, right? Because C is the name of the column that we gave it up here. As preferred pet type. From CTE. Let's run that. Cool, so now we got our array aggregation. So now our column got transformed into an array of values, and we gave it an ID of 1. I'm giving it an ID of 1 to help sort out the final result, because what they expect is they expect this to be sorted 18 to 60 here. And so in order to do that, I did it a hackish way by giving it an ID, and then I'm going to sort by ID. Okay, but what we want to do is we only want distinct items in the array, and we want the count. So what we can do is, and I wish I had more space on the screen. Okay, that works. So what we want to do is not necessarily from CTE. We want to clean up that CTE expression. So what we're going to do is select C, count star as count C, rank over order by count, order by everything we're running into, descending, highest to largest. From CTE, we're going to group by C. We're just going to call this a subquery. Okay. What happens if we just run this? Let's see how this looks. Run that. We want to single out the highest ranking one. Let's expand this again. Where rank equals 1. Let's run that. Okay, cool. So now we only have an aggregation where the count, or we called it a rank, RNK, where the ranking is among the highest because it's ordered by count, descending from highest to lowest. We just have to clean this up a little bit more to give it the count column. So what I can do now is, what we're going to do is we want to select age group name. Oh, I should call that age group. We're going to select age group, preferred, pet type, that's our array, and count, max, count C, max count C as count. We'll call this count. Okay, let's run this, see how this looks. Alright, and so we see the expected result, and now we look pretty close to the expected result. Our 18 to 30 age group looks, this is expected, and this is what we have. So it looks pretty damn close. So what we have to do now is we have to repeat this for all the other age groups. So luckily, I have all this written out already. Cool. Let me just run this again. So now what we're going to do is we're going to union all these on top of each other. Okay. So we're going to have to union this result also, which is will be our 30 through 45 age group, and we're going to bring in this aggregation on top of that, on top or below it. And so what we can do is we have to add the word union down here. So when you're unioning tables, you can get rid of the semicolon and just proceed, and the semicolon will go on at the end. Union, and we're going to select our next age group. Okay, so go from 18 to 31 through 45. Union. Our 46 through 60 age group. And our last age group, which we're going to union as well, is the people who are 61 and above. So we're going to union all of these. Got ahead of myself. Run that. Okay. Cool. So look at the expected result. So the counts are 2, 3, 2, and 2. We got 2, 3, 2, and 2. But our age groups are out of whack, right? We have to go from 18 to 30 to 40 to 60. Right? So we have to order this. But we have the ID here, right? So that's why all we have to do now is just select these 3 columns and then order by ID. So I'm going to bring in code to fix that up. Paste this in. These are the 3 columns we want. Order by ID. Let's run that. And the test pass. So I think that's pretty cool. So that's quite a long query where we're unioning a lot of things, but that's what you have to do when you're going into objects and then you're doing rankings on top of the data that you pull from there. So let's move on to another SQL puzzle. Students to expel. Let's consider a case where we have a students table and a courses table, right? And so we're going to expel all students where if they have a score below 50. I think that's how it works. Expel students who have scores below 50 and students that don't. Students who have an ID here, right? Students are in this table but don't take any courses. So students who are inactive. A student who quits is defined as a student with no records. A student who is performing poorly is defined as a student with 3 or more courses. Okay, yeah, a student with 3 or more courses with a grade less than 60. So let's see our student table. Select start from students. Right, so this is what our students look like. And I think the other table is called courses, right? Students courses, right? So we're going to have to do a joins query, right? So some of these student IDs here, they're not showing up in the students table. So some of those students will have to get kicked out. So the way I solved this is I did use another union where I split this between quit studying and failed in, right? Right, those are my 2. Our expected result is, because we're going to have a quit studying and a failed in. And what we have to do is we have to use this SQL function called string aggregation. So earlier we did an array aggregation, but a string aggregation is similar, where instead of shoving everything into an array, what we're going to do is we're going to slam everything together into one string. And so to do that, you have to build out the string that you want, and then they get put together. Okay, so let's create our first joins query. And let's clean this up a little bit. And let's see what this left join will do. Okay, so we joined the student table on the courses table, and as we see, there's 3 students down here where they didn't show up in courses, right? And so these will be students who are not participating, right? Because if we look at our expected results, these are the 3 students that will get the quit studying label on them. So all we have to do is we just now have to query distinct students where this column here, where the student ID column is nullish, right, where it's null. All right, select distinct ones where it's null. Ideally, it should be dynamic. So select distinct ID as student ID, name, and then quit studying as reason from this subquery here. Where student ID, where this column here, this column, is null. Run that. Okay, so these are our 3 students that have not been signing up for their courses. And what we have to do is we have to union now on top of it the students who are participating but who are experiencing failure. I'm going to use the union word. Let's build out our next query. Select c.studentID, name, string aggregation, course name, separate them, score, from students s join. Now this is tricky where we can always put a subquery inside a join query. Select star from courses, order by course name descending. And that's because if you look here, these aggregations are the course names in some sort of alphabetical order. On s.id equals c.studentID. Where the score in the course is less than 60, right? We're picking out students that are failing. And c.score is greater than 0. So we're not going to worry about nullish results. Group by c.studentID. Okay, let's just leave it there. And order by student ID. So now we have 3 columns here. Let's see if this works. No, our column names are not lining up. Let's just call this as reason for now. Oopsies. It don't like this. Let's do course name. C.course name must appear in the group by clause. Okay. Okay, so now we have all these student IDs and the student names and the classes they took where they were failing, right? So James took 3 classes here, and these are classes where he was failing. David was failing in all these. But instead what we want to do is we want to aggregate the course names and the grades, the scores they had in those courses. So that's really all we have left to do. And so for that, that's a little tricky. So what we have to do is we have to concat, and we have to, our first part of our string will be the flag of failed in space, and then we're going to have a string aggregation. So we're going to aggregate a concatenation of the course name and the score. Concat course name. You need to give parentheses. The score has to be stored in parentheses. Score, closing parentheses. Just separate them with a comma, right? This has to be casted to a text. The string aggregation has to be casted to a text to help it with concatenating. Let's see if this runs. Got it. Okay, cool. Okay, and it's not going to quite pass the test. I don't think so. Because let's attempt to pass all the test cases. Give it a second. Yeah, so we don't pass all the test cases because some of these aggregations are too small, right? So we have this, there's only one class here, only one class here. This only has two classes. And the specification in the test is like we only want students where they're failing 3 or more, right? So to do that, all we have to do is just add on something to our group by. So we're just doing having, right? Having count greater than 2. Let's just try to attempt. There we go, and we passed all the tests. So all these aggregations have 3 or more courses included along with the scores. Just to give you an idea about the solution I just gave for this. Yeah, so if we go to the discussion on this, we go to the solutions, right? So these are what the other solutions looked like for this courses and students puzzle we just did. And some of these are pretty long, you know, these are pretty verbose. They're decent solutions, you know. They're doing a similar thing, they're doing a string aggregation. So these are the way other people saw, but this is my solution here. So the solution we came up with is pretty good compared to even the top ones, right? The best ones. It's quite compact. So yeah, try it out on your own. Maybe you'll come up with something that looks pretty good. And I'll have the nice links posted in the description. So like and subscribe, and happy coding.